Now, let me share yet another very common but very relevant and very pertinent situation. What we have is there is a chain. It could also be a rope, does not matter. There is a chain of length L and of mass m, that means mass per unit length lambda, which is m by L, right? Let me call it capital M for convenience. Let me call it capital M by L. Capital M is the total mass and small l is the total length. And it's put vertically like this and is at rest. This end resting on the ground, this end just held so that the whole thing is at rest. And then I release the chain. What happens is the end A falls, the end B, it starts to settle on the ground. Right? The chain starts to settle on the ground with more and more part of the chain falling. At some instant of time, the upper end of the chain would have fallen by an amount y. The upper end of the chain would have fallen by an amount y. And what we want to find is, at that instant of time, what is the force that the ground exerts on the portion of the chain resting flat on the ground? What is the force exerted by the ground on the portion of the chain resting on the ground? First of all, how much of the chain is resting on the ground? If y units has fallen, that means there must be y units resting on the ground. Yes or no? There must be y units resting on the ground. And the mass of this y units would be mass per unit length into y. Mass per unit length into y. Yes or no? Right? Do you all understand this? Now, let's understand. You might be initially wanting to believe that the ground will exert a force which would be just the weight of this portion. The mass of this portion is lambda y into g, and you would want to believe that the ground will just about exert a force that would be lambda y into g. But that's not the case. What really happens is, at an instant of time, when there is y units resting flat on the ground, this chain, the end A would have fallen y units, and the velocity acquired by every member of this, assume it remains vertical, the velocity acquired by every member of this AB, this unit which is L minus y, is given by v squared equal to 2gy. Yes or no? Right? Now, what's going to happen in a small time dt after this is the following. There is going to be a small mass element dm of the chain. There is going to be a small mass element dm of the chain which is falling vertically with a velocity v like this dm, and it'll rest on the ground. That means right after hitting the ground, what would happen is, I'll assume that the collision with the ground is perfectly inelastic, so that the portion that is resting on the ground, the portion that comes to rest on the ground, does not rebound. So now this dm, additional dm, will get added to this mass m. But in the process of adding this dm, what is the price that one would have to pay? Just before it hits the ground, collides with the ground, it has a velocity v given by v squared equal to 2gy. Now, right after it hits the ground, its vertical velocity will become 0. The ground therefore would have exerted a certain upward impulse on m, so that it kills the vertical momentum mv. Yes or no? Therefore, the ground would have exerted a certain force on the chain to cause this velocity of this dm to go from v to 0. The ground would have exerted, because there is change in linear momentum of this dm in a small time dt. So there must be a force that would enable this linear momentum to change. So which means it is not just the weight of this portion, it is also the force required to cause the velocity of dm to go from v to 0 in that small time dt. So these are the two forces that would act on the chain, right? Now, this mass dm, just before it hits the ground, has a momentum dm into v. Just after it hits the ground, its momentum is 0, right? That means what's the change in linear momentum? Mass into change in velocity. That's the change in linear momentum. And the rate of, and this happens in time dt. So dp dt, that's the force exerted, thrust force. This is called the thrust force. This force is called the thrust force that the ground exerts so that the linear momentum of this changes from dm into v to 0. And that's an upward force because the ground is going to exert an upward impulse j to cause this velocity to become 0. How about it? Do you all understand everything that I have said here? Right? Now, so dp is dm into v. So dp dt, as you can see, is divided by dt, would be dm dt into v. dm dt into v. Now what's dm dt? What's dm dt? Rate at which mass is added to this. Now, mass at a certain instant of time is lambda into y. This is an instant of time t. The mass that is collected on the floor is lambda into y. So dm dt would be lambda into dy dt. But what's dy dt? dy dt must be the velocity v. So lambda into dy dt, where dy dt is v. So dm dt is lambda v. As you can see, dm dt must therefore be simply lambda v. So replacing dm dt by lambda v, it becomes lambda v into v, lambda v squared. That's the thrust force. That's the thrust force. Yes or no? So then, the total force that the ground exerts, one, the weight, lambda y into g is the weight, as you can see. This is the weight. And this is the thrust force, lambda into v squared, which causes the linear momentum to become 0. And all that you need to do is v squared replaced by 2gy and then take lambda g common. So this will become 3 lambda gy, 3 lambda gy, where lambda is mass per unit length. So 3 mg by L into y. That's the force exerted on the portion resting on the ground as a function of the height that is fallen. Yes or no? It's an interesting situation, and there are very interesting variations around this. There are times when this whole thing happens in an elevator which is moving up with an acceleration a. In those situations, everything will remain the same. Just replace g by g plus a. If the elevator, if this is the floor of an elevator moving up with an acceleration a, then the g effective will become g plus a. Replacing g by g plus a, you're going to get past this. Yes or no? Thank you so much. Bye-bye.